The journey from discarded scrap to a precision weapon begins with brute force and extreme heat. Deep inside the cylindrical forge, temperatures soar past 2,000 degrees Fahrenheit. This intense thermal energy alters the molecular structure of the rigid coiled spring. By breaking down the internal stresses, the steel becomes highly malleable. The hammer shapes the foundation. Directing the glowing bar against the anvil horn concentrates the hammer's compressive force. Drawing out a sharp tip requires steady rhythm to prevent the cooling high-carbon steel from fracturing under sudden stress. The profile emerges. Once the heavy forging concludes, the chaotic hammer marks must be refined into flat planes. Locked onto a magnetic chuck, the blade meets the aggressive bite of a surface grinder. The abrasive wheel strips away the oxidized scale, revealing clean carbon steel underneath. Switching to a belt grinder establishes the initial edge geometry. A consistent bevel angle is crucial for the blade's structural integrity. The workpiece is then clamped to the bed of a milling machine. The spinning cutting head carves a deep central groove known as a fuller. This trench removes excess mass from the blade without compromising its overall rigidity. It makes the steel faster. Machines remove material quickly, but finalizing the blade's contour demands the tactile feedback of a hand file. Resting the work on a massive steel drum dampens heavy vibrations, allowing for precise sweeping strokes. As secondary components take shape, drilling through dense alloy requires constant lubrication. Submerging the piece in cooling oil prevents the high-speed drill bit from overheating and losing its temper. The build expands beyond a single blade, requiring a complex secondary spearhead to act as a counterweight and guard. A careful scribe line on the steel billet sets the boundary before it enters the coal forge. Coal provides a deeply concentrated, oxygen-deprived heat source. It brings the thick steel block to critical forging temperatures rapidly, softening the billet for the heavy strikes ahead. An angle grinder cuts away the bulk of the waste material, showering the shop in high-carbon sparks. This aggressive stock removal dictates the weapon's final silhouette. Secured in a heavy bench vise, a bastard file trues up the rough-cut edges, creating a perfectly symmetrical profile. The true character of the piece emerges under a rotary tool. Small tungsten carbide burrs spin at thousands of revolutions per minute to carve intricate details into the cold steel. The hardened bit bites into the surface, turning a utilitarian counterweight into a highly deliberate, sculpted anchor. A hydraulic press delivers tons of silent downward pressure to flatten another glowing block. Unlike a hammer, the press forces the steel to spread uniformly outward in a single motion. A quick pass on the belt sander cleans the forged edge. Moving to the machine lathe, raw round stock is spun at high velocity against a stationary carbide cutter. The initial passes through the cylinder, preparing it for a complex stepped profile. By incrementally feeding the tool bit inward, the craftsman controls the final diameter to within a fraction of a millimeter. This exact precision ensures a flawless, tight tolerance fit with the surrounding guard components. With the shaft turned down to its final critical dimension, a tap and die handle manually cuts deep threads into the metal end. These coarse threads will lock the heavy pommel permanently into place, without relying on fragile adhesives or weak pins. Switching the lathe cutter allows for aggressive plunging cuts. The sharp bit carves deep, parallel grooves directly into the rotating shaft, shedding curled metal chips with every rotation. These recessed rings will eventually provide a mechanical locking surface for the outer handle material. The internal architecture is complete. The handle relies on the natural shock-absorbing qualities of dense hardwood. Mounted on the lathe, a sharp gouge rapidly shears away the square corners, taking the block down to a smooth cylinder. Sandpaper refines the ergonomic swell of the grip. The spinning abrasive closes the wood grain, leaving a slick, splinter-free surface before the piece is separated with a hand saw. Pressing the wood onto a heated tang is a traditional technique called burn fitting. The scorching metal chars its own exact negative shape directly into the interior walls of the handle, ensuring a precise, zero-tolerance friction fit. A heavy layer of two-part epoxy permanently marries the wood to the steel core. Finally, a tightly bound cord wrap compresses the assembly while the glue cures. The textured cord provides lasting, all-weather traction. A soft cloth buffing wheel, loaded with micro-abrasive compound, delivers the final mirror finish to the steel. The rapid friction erases microscopic grinding scratches, leaving a highly polished surface that will actively resist rust and environmental corrosion over time. As the gleaming steel components meet the dark leather bench, the disparate elements finally come together in precise alignment. Sliding the heavy crossguard and threaded pommel into place locks the entire structure into a tightly tensioned state, eliminating any internal vibration. What began as a rusted, discarded piece of industrial coil spring has been fundamentally transformed through applied physics and stubborn will. Every groove milled, thread tapped, and edge filed is what its balance and reliability now rest on. It is a lasting testament to extreme heat, relentless pressure, and calculated mechanical design. The raw chaos of the scrapyard has been tamed into a disciplined, functioning whole. The metal remembers the fire.